Yeah, good morning, everyone. My name is Hardik, Hardik Gohel. I'm a director of Applied AI Research Laboratory at University of Houston. And today I'm going to talk about hybrid-based, hybrid AI-based cyber test automation and monitoring system. Basically, you will be seeing like architecture and design. And I'm going to discuss on the technical part and some of the things that we haven't included in the slide because we decided to present this at last week, and because this project is in a collaboration with federal agency, we have got approval of limited content to put in public. Okay, but yeah, I'm available to give any kind of questions you have after presentation or during the presentation. So that's from my side. So let me start with. Here is about me. That I did my PhD in computer science in 2015, and since then, I have been a part of this different types of research that is related to the AI in cybersecurity. So in 2010, I started working on social media, and then ended up with social media security, and then I did a PhD, and then I came as a postdoc, and since then I'm working with the Department of Defense on the different projects. This is a subject area of a specialization in a project of especially AI project. I have completed like 5 federal, 2 industry projects, and out of these projects, I do have like more than 30 collaborative publications in the proceedings and journals of national and international. So basically, what is the objective of this research project? This is not actually a research project where we are developing like mathematical calculation or the formula, but it's applied research. And we focus more on the optimization part, we focus more on the automation part, and obviously the engineering is there. So basically, the primary goal of this project is to advance understanding of digital twin predictability. So nowadays, like you will be seeing, the digital twin is in market. Okay, lot of infrastructure. So currently, government is focusing on 4 different types of research aspects in a STEM, and one of is infrastructure, and physical security, cyber security, kind of the things. So basically, this digital twin predictability in the sense that we do have physical infrastructure and process set up in a system, how we can make it virtual. Okay, and that virtual version of the physical infrastructure we will be using to do some penetration testing and testing of the security, especially cyber security. So basically, this digital twin predictability and its utilization to overcome the knowledge gap of the cybersecurity characterization of the nuclear power plant system of this project. This project has a capability of a transfer learning on other types of physical infrastructure. You can also count like road, railway, water well, and other nuclear plant, other energy plants, etc. So basically, what we are trying to do is like we are trying to create a virtualization as a part of digital twin, and then we perform automation, cyber analytics testing on this specifically digital twin to see what type of security issues, cyber security issues it has. So basically, again, these goals will be fulfilled by developing advanced early detection, prediction, prevention, and optimization of nuclear digital twin cybersecurity prediction model that will improve with the prediction ability and computational efficiency. So basically, like we are trying to do here, we have designed a framework. That framework is going to come the next one. So this is not the final framework. This is the initial version of the framework. There is a detailed framework, but again, because we do not get the approval of information release on the right time, so I just put this one to present here. So basically, what you are saying here, this nuclear plant, nuclear power plant, okay, or let's say any kind of nuclear infrastructure system right now. We are creating a digital twin system for that. Okay, so basically this project is in a process. We have done similar type of projects for the Windows. So let's say we have created virtualization of the Windows system using different hypervisor. That's what I'm going to explain. But this is a general framework. And this is what I put it for the non-technical people, those who can understand as well. So in this framework, how does it work? The flow of the process. So let's say, for example, we do have actual physical nuclear infrastructure system. Okay, so there are two things. The first is the infrastructure. The second one is the process. And we are trying to virtualize these two major things. Okay, so the digital twin is the kind of the process that we are using to virtualize this infrastructure. Okay, so now what we are using and what type of technology we are doing, this is still in the process, but we started virtualization of the Linux and Windows operating system using Zen and KVM hypervisor, where we use the open source libbmi library to collect the data of the kernel. But for this one, we are in the process of doing an experiment with ARM processor. So basically the ARM processor virtualization, if we can do, and it is a little complicated because it requires like a lot of system software and programming. So the same type of technology can be transferred for the digital twin virtualization. Once we have this platform, which we call as a digital twin virtualization, what we are doing, we are developing set of custom malware and rootkit to penetrate that digital infrastructure. And once penetration completed, we are collecting during that penetration process. I mean, like there are two types of malware we are using. The one is open source that let's say we are downloading from the VirusTotal, and the one we are actually creating our own malware. So we are trying to do we are trying to attack on the virtual digital twin of the infrastructure, and then collect the data. And then we do this, classification of like whether the system is infected or not infected, or if there is any anomaly in a pattern of the operations, if there is any other kind of issues with it, if the behavior of the system process is changing due to some kind of malware attack, what type of anomaly is it, or what is the specific set of change that has been seen. So that is what the part of this entire process. So you will be seeing here that this nuclear power plant digital twin is a virtual version of the digital infrastructure. Here it is like a kind of operation. So this operation is nothing but it is the control system that connects these two different components. This prediction is the advanced predictive analytics that what we have developed. And there are two types of there are two types of different findings. The first one is obviously the classification using machine learning and deep learning algorithm. I will give one example, let's say random forest or let's say deep neural network. Okay, recently we started customizing our algorithm that does all this automation and kind of optimization technique by itself. And recently, last week, we have seen a really great result by incorporating the AlphaFold, that is the latest deep learning algorithm developed by the Google. So you will be seeing here that this is the framework of the infrastructures. The details of the framework, that's what I already explained, but I would like to go a little bit on the details. That the cybersecurity orchestration test bed for automation and threat monitoring of the nuclear power plant system. Again, we are doing this for nuclear power plant system, but this knowledge can be transferable to the other technologies. We are mostly targeting, let's say, DOE, National Lab, nuclear site, for example. We can also target the water well. Okay, we can also target the infrastructure of this energy provider. So this solution is transferable to those type of things. So the digital twin, operations and prediction, the nuclear power plant digital twin component is to allow to design development of digital twin controller, and that controllers that collecting the data and helping to store the data into the SQL server of the nuclear power plant, as well as to extract, transfer, load various type of digital twin data. The intelligent driver and monitors, that's what you can see here. So here you see this intelligent driver and monitor. So this intelligent driver and monitor in the sense what? Let's say for example, this is entire automated system. You have one click. Okay, you have to do just one click. In one click, what it does, it will get the virtual version of the infrastructure which we call as a digital twin. It will start attacking or penetrating using this custom and open source malware. It will collect the data, store the data into the SQL server. I'm specifically talking about SQL server because the entire project is in Microsoft ecosystem. And in SQL Server, there are the stored procedures available for analytics. Okay, so let's say machine learning and deep learning and all these different types of NLPs and computer vision we can do. So here is the thing that this is specific, the test bed that what you guys are seeing here, it is completely automated and it is to avoid any human error, and that is the objective of this specific framework. That as a test bed user, you just need to click on the one button and that will does entire process. Yesterday I was talking to one guy and he asked me the question which I think I can include in this talk. He said okay, how long does it take? Okay, you are talking about the deep neural network. It is doing attack on the virtual system, collecting data, transferring data into the SQL server, doing this deep learning process. So does it take like 2-3 months or something like that? That's what his question was. And I was like, no, it takes only 2 or 3 hours. And what's the size of the data? The size of the data is minimum 500 to 600,000 rows, and maximum it can be anything. So now the question is like, why is too less time? Because it requires a lot of time to do a deep neural network or deep learning processing. The reason, we were also having the same issue that let's say we train the algorithm and test algorithm in the real time. So nowadays, like you have seen so many solutions outside in the exhibition that they already have trained algorithm on some open source or synthetic data. No, we are training algorithm in a real time. Okay, so why it is less time? The reason that we recently started doing a parallel processing or computation of this training and testing using a Tesla GPU server. And that is far faster. So we do have our own premises. It's not cloud-based, it's own premises, Tesla GPU server, where this entire computation is done. Okay, and that is the reason it takes 2 to 3 hours. Or now, let's say we have this image data. Now we have, video data. Yeah, video and images takes a little bit of more time, but the data that we are dealing with right now, it's all like, a text numerical. Okay, but again, in video, audio is also the same kind of time. So that is what this is intelligent drivers and monitors designed to automate this digital twin data extraction, loading and transfer. So basically this intelligent driver and monitor does the entire task automatically. Okay, and that's what the three here. Yeah. So yeah, this is what the project that we have already implemented as a part of in a collaboration of Florida International University as a part of the cyber test and automation monitoring system for Department of Defense. And this project was multi-million dollar funded project, and this is entire system that I just explained to you, but this is not the digital twin. It is the Windows and Unix operating system virtualization process. Again, but digital twin is a different. That's what we are pursuing right now. These are the component that what we have built, and these are the most important aspects to make it as an automated process. So the automated database and data pipeline, okay, because I mean, we are data scientists, we are data engineering people, okay. So that's what we are doing. I mean, industry luxury, we do not have enough lab. We have to do the research, application, data extraction, pipeline, everything. The data imputation. So basically, when we were collecting some data, we need a diversity in the data, and that's what sometimes missing because of the behavior of the malware. So what we are doing, let's say some of the data that we do not have a diversified or some missing value, we have tried different imputation techniques. Mean, median, max value, log transformation value, but this KNN, K nearest neighbor algorithm, is giving the best prediction of the data missing value basically. So you will be saying like there are so many synthetic data available, but you don't need to use the synthetic data where you can do this data imputation. Okay, so that will give you the kind of behavior of the similar data that you existing have. Classification and anomaly detection by using deep convolutional neural network and also LSTM, and I told you the other algorithms we are trying. The design of the predictive modeling, that's what the entire framework, and the design of the custom malwares and rootkit when we see that open source malwares are not useful. So these are the component of this entire project where we are developing automated cybersecurity testing and monitoring system for digital twin and other kind of infrastructure. That's it. I'm open for question. Yes.
How do you implement the human factor into this? Things like scale, the penetration, things like that. Are those simulations or?
Yeah. So basically, right now, yeah. I mean, that is what we have experimented. But because this is not the industry scale project right now. This is just for the research. But that Monte Carlo is one of the process that we can do. But because of facilities and the ecosystem of the Microsoft, what we can do, it can handle the more than 36,000 set of pipeline data collection and extraction. So we have done, let's say there is a 3 hypervisor, and each hypervisor has a 5 or 10 system. They all run together and send the data in one SQL server. So SQL server has a capability to get all those data together. So we haven't gone at that level where we have 1,000 or let's say 10,000 system. Yeah, but like this is one of the approach, and I may need to look into that for sure.